Welcome to this tutorial on composites design. During this video, you will acquire knowledge about the manual approach design method on CATIA 3D experience. Before starting the demo, let's talk about the manual design approach. The manual design approach is the simplest approach within 3D experience composites. This approach is typically used when design complexity is low, meaning a small number of plies, ply drop-offs are minimal, etc. For this approach, the user defines each ply manually using contours and support surface. For this tutorial, we will use this geometry, an engine part. Download the file attached to this tutorial, and save it on your computer, in a directory of your choice. By the end of this tutorial, you will be able to log into 3D Experience and prepare the environment, define composites parameters, create plies group and plies, view plies sections, modify plies geometry, and finally, manage plies. Let's get started. First of all, you have to log into the 3D Experience platform. Open the 3D Experience login window, and put your ID and your password. Then, click on Login. Once you have logged in, click on the compass and search in the search bar for the Composites design application. Launch it. Once the application is opened, click on the plus button at the top right and click on Import. Import the file named frame_engine.3d.xml that you put in the directory of your choice, and as soon as the import is complete, press Ctrl+O to open the part, or right-click on the 3D part, and click on Open. Ensure that the part is open in the Composites design application. Before starting composites design, it is important to define the parameters of the composite. Composite parameters play an important role in composites design. The composite parameters must be defined before proceeding with the composites design. The composite design commands are only active after the composite parameters have been created. First, let's add materials to composites parameters. In the 3D Experience platform, materials are objects containing the properties of the associated materials. A material consists of a default set of properties and domain definitions that are used to determine the material-related characteristics. You can create new material or import an existing one. Composite design starts with material definition. All material data is created, stored, and accessed on the 3D Experience platform. All composite models require at least one defined material. Users can easily add, edit, or remove material properties from the material database. If editing material properties, these changes will propagate to all referenced models. In our case, we will import existing materials. Import the cpd_htm21.3d.xml file that you put in the directory of your choice. It contains the material we will use in this tutorial. On the Grid Design tab of the action bar, click on the Composites Parameters icon. You can also use the Composites Parameters icon on the Grid Design and the Zones Design tabs. In the Materials tab, click on Add Material. Select from Database icon and search for cpd_htm21. In the search window results, select cpd_htm21. Once we added the composite material, all its composites properties are displayed in the Material tab. Now, let's edit the fiber directions. The material directions are the predefined parameters that indicate the fiber direction of the plies. Each direction is associated with a color. If required, you can add, edit, or remove directions. Then, let's define a rosette. A rosette is a graphical representation of fiber orientations. It defines the referential in which the fiber direction of plies will be defined. It is computed from a 3D axis system to a given location on a surface. The x direction of the axis system represents 0 degrees fiber orientation and the y direction represents 90 degrees fiber orientation. In the Rosette tab, click on Add Rosettes. In the Rosette Definition dialog box, Specify the axis system. The reference axis system for the rosette is already provided under the axis system node in the tree. A rosette has associated transfer types. A rosette transfer type is a method to compute a rosette from an axis system. The following methods are available. First, with a Cartesian method, the rosette is computed using the Cartesian coordinates. Then, with the 0 degrees guided by curve method, the 0 degrees direction is tangent to the selected guide curve at the projected point, where the rosette is to be transferred. Furthermore, with the 90 degrees guided by curve method, the 90 degrees direction is tangent to the selected guide curve at the projected point, where the rosette is to be transferred. Finally, with the external method, the rosette can be developed externally and selected from the list. The Edit button allows you to select the inputs such as curves or parameters to define the rosette if required. In our tutorial, we will use the Cartesian method. So, select the transfer type as Cartesian and specify the constant model size as 3 mm. Click on Preview Rosette Transfer to display the rosette behavior on the selected surface. You can adjust the density using the slider. When you've finished, click Close and click OK to close the rosette definition dialog box. The first step of this tutorial will be to create a plies group and plies. A plies group is a feature containing the plies and sequences that will be created during the Composites design process. It is a good practice to structure the plies data into plies groups. A plies group contains the plies which are sharing the same support surface. A new plies group must be created whenever a new support surface is used. In the plies design section of the action bar, click on the plies group icon. The name of the plies group is automatically populated, which you can rename later based on your requirement. Also, observe that the stacking feature is generated in the tree. Select the base surface. The draping direction is displayed in the geometry area. It indicates the direction in which the plies will be laid on the surface. This direction is driven by the positive normal direction of the joined surface. The rosette is automatically populated in the panel. Click OK. A plies group has now been created. A ply in CATIA Composites design is defined by closed contours on a surface, material, fiber orientation and rosette. The shape of ply is driven by the shape of its base surface, which is the surface on which the plies are generated. In the plies design section of the action bar, click on the ply icon. Click on the plies group previously created in the specification tree. Here, we have only one plies group. In the Geometry tab, select the curves from the 3D area in a sequence to define a closed contour for the ply. A green tick mark indicates that the ply contour is closed. If the contour is open, a red cross will appear. In the Attributes tab, select the material, direction, and rosette. The drop-down lists for material, direction, and rosette display only those attributes that are defined in Composites parameters. Click OK. A ply is created and the plies group node is updated in the specification tree with a sequence and a ply for that sequence. The ply contour is also displayed in the geometry area and the color of the ply boundary is driven by the directions defined for it. Now, we will create multiple plies. Generally, manual plies are created one by defining the contour and the attributes manually for each ply. If the plies have the same contour and attributes, we can simply copy and paste the required sequence in the same plies group to speed up the process. Using the copy-paste option of the action bar, create 7 more sequences and plies. Observe that the same ply is copied in all sequences, however, sequence numbers are different. Now, let's see how to view plies sections and modify plies geometry. We want to visualize the thickness of the part in the 3D area. Let us create the sections of the plies previously created to visualize their location on the surface and the thickness of the part. Unhide the ply_section plane. We will create the plies section across this plane. In the Review section of the action bar, click on the plies section icon. Ensure that the Complete Stacking option is selected, and select the section plane. Select the surface option as display type, click on Apply, and then OK. Zoom in the Part section to have a better understanding of plies positions on the surface. You can select the ply sections in the specification tree and relate their positions in the 3D area. Observe that the first ply is lying immediately on the surface and the second ply lies on the first ply. Similarly, the last ply created in the specification tree is at the farthest position from the surface. Since we created all the plies by copy-pasting the first ply, they have the same geometry. Now, we will modify the ply geometry for the middle ply. It is always recommended for a composite designer to respect some basic rules while creating plies. One such rule is to have bigger size plies at both the ends of the stacking while the small size plies should be at the middle level, maintaining a smooth and steady drop-off. In the plies design section of the action bar, click on the limit contour icon. Select sequence.3 to sequence.6 as entities to be trimmed. Select the transition_curve as relimiting curve. Selecting the relimiting curve will highlight the curve in the geometry areas along with the limiting direction. This direction indicates the side of the curves on which the ply material will remain. Select the multi-selection icon and specify the staggering value of 3 mm. This value indicates the distance between two successive cut plies. The green arrow on the curve indicates curve orientation, and the triangle indicates a staggering direction. You can reverse their directions by using the invert button. Select the parallel mode option and click on Apply. Performing any operation on created plies will update the plies sections automatically. Observe that the contours of trimmed plies are updated in 3D areas. Hide the engineering geometrical set and zoom on the surface to understand the modifications in the trimmed plies. Sequence.3 is the first cut ply. Observe the ply sections of trimmed plies. The distance between two cut plies is the specified staggering value. Let's see how to manage the ply attributes using the stacking management command. The stacking is a feature that contains all the plies groups, sequences, and plies of a composite part. There is only one single stacking in a CATIA composite part. In the Review section of the action bar, click on the Stacking Management icon. The Stacking Management panels display all the information about the stacking entities like plies group, sequence, plies, and their attributes. Using the Stacking Management tool, you can modify the component properties like the name, materials, and orientation. You can also reorder plies group, sequences, and plies, modify the sequence of the ply parent, create new sequences or plies, and check 3D contours. Select Alternate Rows as shown and select the Multiple Row Addition icon from Tools palette. Change the Orientation Name option to 90 degrees and observe the changes in the selected entities. Select the Sequence option as Entity Level and select All Rows. Then, select the Multiple Row Addition icon again and rename all the sequences as shown. Observe that names are changed for all sequences. Similarly, rename the plies. Click OK and observe the changes. After the plies definition has been completed with stacking management, the part is fully designed. It would now be helpful to have information about the part such as area, volume, mass, center of gravity, and cost, when the material information is available. In the Review section of the action bar, click on the numerical analysis icon. Click on the part and observe the different parameters displayed in the analysis section of the GUI: area, volume, volumic mass, areal mass, center of gravity, and cost. Additionally, the persistent feature is interesting. This allows the information to be stored in the model in the tree to access later. Also, it is important to know that the numerical analysis can be performed at the stacking, ply group, ply, and cut piece levels. Finally, this data can be exported to a spreadsheet for additional manipulation. When you've finished, click OK. It can also be interesting to use the core sampling tool to make 2 core samples at the 2 different thickness areas. In the Review section of the action bar, click on the Multiple Core Samples icon. Click on the part, and click on 2 different areas of the part, which have different thicknesses. Observe that the 2 core samples created have different thicknesses, and a different number of plies. When you finished, click on Apply and then, click OK. Observe in the specification tree the 2 core samples that you just created. Finally, the Web Widget 3D Annotation Insights can be used to review a part's composites definition from a mobile device, tablet, or even smartphone for design review or manufacturing and repair purposes. Click on the compass and search in the search bar for the 3D Annotation Insights application. Launch it. Click on Open Content and search in your collab space for the 3D part you just saved. Open it. Explore the different options of the application. You can have a visual representation of the plies, as well as the important information about the 2 core samples you created, as well as all the information about all plies. This is the end of the tutorial. In this video, we learned how to log into 3D Experience and prepare the environment, define composites parameters, create plies group and plies, view plies sections and modify plies geometry, and finally, manage plies. Don't hesitate to watch this tutorial again, and reproduce all the steps by